Hello viewers, in this video we'll be solving three additional problems. Number one is find the inverse of this function. F of x is minus roots of 9 minus x, and state the interval where the graph of the f inverse is above the x-axis. And the number two is a similar question, just the function change a little bit, so the same story. And question number three is to sketch this graph, this exponential graph, and where to find its range. So let's start with the first question. So the first question says we should find the inverse. So to find the inverse, what we can do is we can find the domain of the function. So what is the function? The function it's minus this. And if we want to find the domain of the function, it's just 9 minus x greater or equals to 0. And this will give us that x is less than or equals to 9. And the range of this function, since this is an even root, is going to be non-negative. And if you multiply by minus both sides, this will be less than or equals to 0. And what is this? This is our f of x, which is less than or equals to 0, which is like saying y is less than or equals to 0. So the range, it's simply from minus infinity to 0 close. Right. Now, let's even have a feel of the diagram of this function. How does it look? So here we know that at x equals to what? As x equals to 9 is going to be 0, right? So let's say this is 9 here. But we're interested in the part where x is what? Less than or equals to 9. So we are interested in all the parts from here. So this is just going to be something this way, actually. So this is the graph. But because we have a minus here, so it means it has to be reflected across the x-axis. So it's just going to be something like this. So this is minus 9 minus x. Okay. And now you can see the range of this graph is also minus infinity to 0, while the domain is x less than or equals to 9. So we want to find the inverse. So let's go ahead and find the inverse. To find the inverse, we set y to be minus 9. We said y is equals to minus the root of 9 minus x. So we interchange between x and y. So here we already have our condition. What is the condition on x? The condition of x is is coming from this domain. So we put it there. And here we can interchange between x and y. So this is x, and this is going to be y. So now we interchange. So the condition now is on y. If you square both sides, you have x squared is equals to 9 minus y. So what is y? Y is just going to be 9 minus x squared. So we have f inverse of x equals to 9 minus what? Minus x squared. So what is the condition on the domain of f? Remember, the domain of f inverse is equals to the range of f. So what is the range of f? Is this 0. So it means we're going to have x less than equals to what? 0. The x less than equals to 0 is the same thing as minus infinity to 0. So because we know that the domain of f inverse is equals to what? The range of f. So this range of f is the one that will give us the condition here, because whatever is x here is coming from the domain of f inverse. So now what do we want? We want the region where it is above the x-axis. So we can go ahead and just grab this function directly. This is nothing but the parabola opening down. This is 9, because this is what? This is minus x squared plus 9. The coefficient of x squared is negative, so it's an open down. And here at 0, you will have 9. Yeah? So now we can get what is the x-intercept here. Just set what? 9. Just set the function to 0. 9 minus x squared equals to 0. And we'll get x squared equals to 9. You will have x is plus or minus 3. But we cannot take plus 3. We only take minus 3 because we are on the negative axis. We're on the negative axis. Don't forget, what is the domain of f inverse? It's only the x less than equals to 0. So you can only take the left-hand side. So from here now, you can see that when we talk of above the x-axis, so above x-axis, it's simply what? It's just simply from minus 3 to where? 0 close. Because at minus 3, you can see we are on where? On the x-axis. So anything you move away from minus 3, you will see that the graph is what? Is above the what? Above the x-axis. Even at 0, you see it's above the x-axis, it's 9. So that is why 0 is closed. Okay, now let's do another method to solve this one if you don't want to use the graph. If you don't want to use the graph, what we can do, it's just this here. Let me do it in red here. You can say, okay, you want f inverse of x to be what? To be greater than 0. And that means that what? 9 minus x squared, you want it to be greater than 0, sorry. You don't need equality. It's just above. And this means that 9 will be greater than x squared. So x squared is less than 9. If you take root of both sides, you will have absolute value of x is less than 3. And we're supposed to have what? Minus 3 less than x less than what? Less than 3. Is it? So here it's simply like something like this. This is going to be minus 3 and this is 3. You're supposed to be from here to here, right? But don't forget, 3 and minus 3 are open. But because of the condition we have on x here, you can only take what? Something that is less than equals to 0. So it means you can only consider this part. You can only consider the part here from minus 3 to 0. We cannot consider anything 0 to 3. So remove this part. So in this case, we have what? We have just minus 3 to 0 close. So that will be our above the x-axis. Here it's going to be plus everything. So we have minus 3 to 0. Okay, now let's go to the second question, which is like a similar problem. So what only change here is our function. So we'll start in the same manner. We find the domain of f. What is the domain of f? The domain of f, we want x minus 9 to be greater or equals to 0. And this means that x is greater or equals to what? 9. To find the range of f, similarly, as we did before, we'll take this even, everything to be greater or equals to 0. And if we multiply by minus, this will become less than. So this is our y is less than equals to 0. So our range is still minus infinity to 0 close. Okay. So what do we want? Let's see also the graph of the original function. The graph of the original function is what? If at x equals to 9, the same 9. But in this time, the domain is x greater than 9 equals to 9. This is the same thing as saying 9 to infinity. So it means it's going to go this way. Keep going. Yes. but we have minus, so it means we have to reflect it. So this is going to be a reflection here across the x-axis. So this is actually the graph of what? Of f of x, which is minus x minus 9. And you can see the domain is what? Is x is from 9 to infinity, and the range is from where? Minus infinity to 0. All right, so now let's go ahead and find what is f inverse. To find f inverse, we set y to be minus x minus 9. Here, don't forget we have our condition already that x is greater or equals to 9. So here become x is minus root y minus what? Minus 9. So here we are interchanging x and y. So let's interchange also the condition. If you square both sides, you have x squared is y minus what? Minus 9. And then you can have y is equals to what? X squared plus what? Plus 9. So what is y? Y is nothing but f inverse of x is equals to x squared plus 9. So here you see what will be the condition on what? On x. The condition on x will come from where? The condition on x will come from this one. It will come from the what? The range here. So it means that x is less than equals to 0. That should be the condition. Why? Because we know that the domain of f inverse is the same thing as the range of f. So any x you are putting here, it has to do with what? The domain of f, because you see x here is the input of f inverse. Okay. Now, so what we can do is to draw the f inverse. And if you look at this f inverse, what do you have? It's just what? X squared, you know, plus 9. So this is open up in a way. It's supposed to be open up here at 9, right? Yeah, because x squared you shifted 9. But you're only interested in the negative part because x is less than equals to 0. So this is our what? This is our graph. And if you look at this graph, you will see that it is above the x-axis from where? From minus infinity, almost everywhere, right? So it's going to be just from minus infinity to where? To 0 close. From minus infinity to 0 close. So this is where it is above the x-axis. So above the x-axis, let's write it clearly. So above x-axis is just from minus infinity to 0 close. All right. But we can still also do the second method. That is, if you don't want to use the graphical method, if you don't want to use the graph of f inverse. So what do you do? After getting your f inverse, just set f inverse. Say it you want it to be positive, greater than 0. And so you get what? X squared plus 9. And you want this to be greater than what? You want this to be greater than 0. And so here you see this will be what? X squared is greater than what? X squared is greater than minus 9. X squared is greater than minus 9. What do? You take square of both sides. You will have absolute value of x is greater than what? This is going to be a negative number here. Okay. So it means you run into what's into an imaginary number. So in this case, you cannot really conclude using this method because you're going to have an imaginary number on the right, and it's difficult for you to really complete it. So the best way to do this is just to use the what? You use the graphical method, right? And though you can see that what? Even if you have, because you already have a restriction on what? on x, you know that any x less than equals to what? 0. If you have any x less than equals to 0, the square of it definitely is going to be greater than what? It's going to be greater than any what? Negative number. So if you don't want to go from here, you can use the fact that what? If you see that any x squared here, any x you take here, because this is where your x is coming from, x is less than equals to what? Less than equals to 0. So for any x there, if you square it, it's going to be greater than any negative number, right? So it means this is always true. This is always true because your x is coming from where? Don't forget, your x is coming from minus 0 to where? From minus infinity to 0. And then you can now conclude that your what? This is always true. So you're above the x-axis is going to be from minus infinity to where? To 0. Okay, let's go to question number 3. Question number 3 says we want to sketch this graph. Now, to sketch this graph, what do we do? It's an exponential graph, so we can start with this one. We can start with the graph of e to the power of what? Of x. We can start with this. Right, yes, we can start with e to the power of x. Or we can rewrite this. If you can see this function, your f of x, we can rewrite f of x as what? 3 minus, this is going to be 1 over e, then x plus 1 is the same story, right? So it means you can start with what? We can start with the graph of 1 over e root to power what? Root of x. And what is this? This is simply 1 over e to power what? X, when x is what? Greater or equals to 0. And this is 1 over e, then minus x, when x is less than equals to 0, less than 0. So we just use the definition of absolute value. Now, let's go into sketching. So this one, this part, you can see 1 over e. 1 over e is going to be between 0 and 1. So it's going to be decreasing. So it's going to be something like this. And here is going to be at 1. But in this case, we are interested only in when x is what? Positive. So you're interested only in the positive part. Let's delete the what? The negative part. Then secondly, we have this one. This one, as you can see, this is going to be just a reflection of this one across the y-axis. So this is just going to be this one. So this part is what? The first part is 1 over e to power x. And this part is what's 1 over e to power minus x. Is that okay? So let's see, what can we do next? Now we can, because there is a plus 1, remember this is just plus what? Plus 1. So plus 1 simply means we do what? We do horizontal translation 1 unit right. Yes, 1 unit right simply means just move everything 1 unit right, everything. So we're going to have this one. Let's see. So instead here, you can see here is 0, 1. We'll just move everything right 1 here. And this is just going to be minus 1 and what? And 1. And this will still remain our what's? Our horizontal asymptote will not change. So we have something like this. Okay. Now, we now need to what? We need to reflect everything. So this is what? This is the graph of 1 over e x plus 1. Okay. Now, what next? We now need to what? We now need to reflect everything across the x-axis. Why? Because of this minus here. And if we do that, reflecting across the x-axis, don't forget that this point is minus 1, 1. The point will just become here, which is just going to be minus 1, minus 1. So this side will go something like this. And the negative part of x will just go something like this. So this is what? This is minus 1 and minus 1. Okay, so we have one more steps to do. And what is that step? We have to do the horizontal vertical translation 3 units up. So let's do that here with this arrow here. So now we have to go vertical translation 3 units up. So that means we will have something like this. Don't forget, we are not interested in the upper part. We're interested in we are shifting the side below the x-axis. So if you move it 3 units, remember here it's minus 1. So if we move it 3 units up, it will be at where? It will be at 2, right? Yes. So it will be somewhere here. This is still minus 1, but now this is where? This is 2, right? And let's move this up a little. So it means this is just going to be from here. And you see we still have our what? We have our horizontal asymptote is going to be at y. It's equals to 3. And this other side we have similar here. It's just going to be something like this. So this is the graph of what? This is the graph of absolute value. Is the absolute value? No, it's just the graph of 3 minus e. You can write it as 1 over e. It's okay. X plus 1. So this is the graph. And from here you can see what is the range. The range, it's simply from where? Range, remember, is the value of y, which is 2. Close. Then we go to the horizontal asymptotes, which is 3. But it cannot be 3, so it's not touching it. So the 3 has to be open. So I hope this video is clear, the solutions. If you have any question, please you can put it in the comment section, or you can contact me. Okay, thank you so much for watching.